This video is going to cover review section 3, which is polynomials. So there's actually a lot of stuff in this section. There's multiplying polynomials with exponents, there's adding, subtracting, multiplying polynomials by foiling, and then ends with division of polynomials. So we start with like the product rule, which just says that when you raise a variable to a power and you multiply that by another one, that to combine them you add their exponents. So if you just look here, if this was, y to the 4th times y to the 7th, that'd be 4 y's, 1, 2, 3, 4, and then times 7 more y's. I'm not going to keep going, but if you just add up all of those y's, you would find that there are now 11 y's. So when you have two variables or numbers, anything with the same base, and you multiply them, you simply combine the exponents by adding them. So something like z to the 3rd times z to the 4th would be z to the 7th. And then example B here has coefficients on the front, so you would just take and multiply out the coefficients. 6 times 9 times 2, which is 108, and then there's z to the 5th, z to the 3rd, z to the 2nd. Add your exponents. 5 plus 3 plus 2 would be z to the 10th, which is where this answer comes from. There's just some additional now examples with raising a power to a power. So when you raise a power to a power, like 2 to the 5th raised to the 3rd, you multiply these exponents together. So this would be 2 to the 15th. Down here, that's what all these examples are. So this would be 5 to the 6th. This one, I've got a coefficient and a variable. So this is 3 to the 4th raised to the 3rd and x to the 2nd raised to the 3rd. Just multiply out those exponents and you'd get 3 to the 12th times x to the 6th. And then you've got quotients. So here we've got fractions that are being raised to a power. You just distribute that power to both the top and the bottom of your fraction, numerator and denominator. So in example D, this would be negative 2m to the 6th raised to the 5th, and then t to the 2nd, z to the 1st raised to the 5th. And then you've got two numerator and denominator that you would distribute the exponent. So that would be negative 2 to the 5th, m to the 6th raised to the 5th, multiply those out, you'd get m to the 30th, over t to the 2nd raised to the 5th, which is t to the 10th, and then z to the 5th, which is this last example here. And then if you took and multiplied out negative 2 5 times, you'd end up with negative 30. And that's where this, negative 32, sorry, or this is. You can either put the negative on the 32 or put it out to the front, same thing. So this box just goes kind of through those rules. So if you are multiplying, two of the same base with an exponent, you add the exponent. If you're raising a power to a power, you multiply. If you've got parentheses with a exponent on the outside, you distribute that in. And if you've got fraction raised to an exponent, then you would distribute that exponent to both the top and the bottom. If you have a number or variable raised to the power of 0, then your answer is 1. So it's not really anything you can work out. You just want a straight memorization. Anything raised to the power of 0 would be 1. So here, this, 4 to the 0 power would be 1. This would be 1. This is a reminder of your negative on the front. So this is the opposite of, this is read as the opposite of 4 to the 0, which would be a negative 1. This is same thing inside here. Negative 4 raised to the 0 power is 1, and then there's a negative on the front. That would be negative 1. And then this whole expression is raised to the power of 0, so it's still just 1. Okay, then we get into polynomials, or an algebraic expression that's the result of adding or subtracting. So each of these are examples, adding, subtracting, multiplying, or dividing. All of these are examples of polynomials. Poly just means many, so you can have a single term or many terms. Some additional vocab here. The individual variable or coefficient on the front of the variable would be called a term, anything that's not separated by a plus or minus. The number on the front is called the coefficient. You can call it a numerical coefficient or just coefficient. And then if you ignore the coefficient, whatever's left is exactly the same. Those would be considered to be like terms. So if you look at the three terms that are here, if I remove off the coefficients, which in this case would be my -13, my 4, and my -1 is really on the front there, then each of these has an x to the third. Because they're all the same, those would be considered to be like terms. If you look at the second example here, if I take off the coefficients again, which are the 6, and the 4, what's left is y to the second, and y to the third. They have to be exactly the same, so you can't have a different exponent. Those would not be like terms. So if you remember, you can combine like terms. This is just a polynomial defined as sum or difference. You can't have, a polynomial can't have a variable in the denominator. So this is an example of something that's not a polynomial. The degree of the term is the exponent, the highest exponent on the terms there, or sorry, on a single term, and then the degree of the polynomial is the highest exponent of the whole polynomial. So if you look at all the terms in this polynomial, the highest exponent would be 3, so the degree of this polynomial is 3. If you have more than one variable, then you add the exponents to get the degree of the individual term. So this degree is 7, this is 6, and this is 8. And then again, to find the degree of the entire polynomial, you take the highest one, which in this case would be 8. A single term is called a monomial, so this would be a monomial. 2 terms is a binomial, this is a binomial. 3 terms is a trinomial, and anything more than 3 terms is just called a polynomial. There's no more special terms for it. Okay, so what we were saying before, you can add and subtract like terms. So if I look at, I'm just going to pull example A. This is addition, so I don't have to worry about the sign in between. I'm just going to combine like terms. So I've got a y to the 4th and a y to the 4th. Add those together. 2 plus 4 is 6 y to the 4th. Then I've got a y to the 2nd and a y to the 2nd. -3, sorry, plus 7 would be a positive 4 y to the 2nd. And then a positive y and a positive 6y, they both have a y to the 1st. So I add positive 1y and 6y, and I get positive 7y. And then the additional example is something like this. You want to make sure that you just distribute that negative into each term first, then combine your like terms. Something like D, you would distribute the 4 in, the -5 in, and then combine your like terms. So this just works through the rest of those examples. Normally, when you write your answer, you write it in descending order, meaning you put the highest exponent down to none. It's not really wrong any other way, but that's the correct format. Okay, now we're going to get into multiplication. So if you think about foiling, if it was 2 binomials, we would just multiply the 2 together. So if it was 2x plus 3 and x minus 4, the foiling term comes from first, you multiply the first 2. 2x times x would be 2x squared. Outer would be 2x times -4, -8x. Inner, 3 times x. And last, 3 times -4, which is -12. And then combine your like terms, descending degree, and there's your answer. Anything more than 2 terms, then you've got to distribute each of the terms in the first one to each of the terms in the second one. So this example actually works it out vertically, but most people find it easier to do it horizontally, which is what I would recommend. So I would do the first term times each term in the second. So 3p squared times p to the third would be 3p to the 5th, because we're going to add the exponents. 3p times 3p squared times 2p would be a positive 6. P to the 2nd, p to the 1st would be p to the 3rd. And then the last here would be 3p squared times -8, -24p squared. Then I'm going to multiply the second term times each of the ones in the second. So negative 4p times p to the third would be a negative 4p to the fourth. Then multiply it times the second term, negative 8p squared, and the last term, positive 32p. And then the last number gets multiplied times all three. So 1 times p to the third would be p to the third. 1 times 2p would be 2p. 1 times negative 8 would be negative 8. Sometimes people like to line up the ones that are the same term. So you've got a p to the third and another p to the third. You've got, so I would cross it out there. I've got a p to the first and 32 p to the first, so I can add them there. And then the negative 8's by itself. So from there, I would just take and combine all the ones that are the same. You don't need to do that step, though. I can just go through. So there's only one p to the fifth. The next one down would be a p to the fourth, which is negative 4p to the fourth. That one's gone. P to the third, I've got 6p to the third plus p to the, that should be to the third. So that's a 7p to the third. That's gone. And then I've got negative 24p to the second, negative 8. So negative 32p to the second. Those two are now gone. 32 plus 2 is 34p minus 8. So just be really careful. That's a lot of steps in there. It's easy to make a mistake. Okay, the rest through example 6 is all that foiling that we had talked about. So special products, there's three really different kinds of special products. And these are just shortcuts. You don't have to know how to do these, but if you do spot them, they're definitely going to help you move faster. So if I have two binomials that are identical with the exception of the sign in between them, one's a plus and one's a minus, then if I square the first one and square the second one, I kind of put a minus between them, and I would get what would happen if I FOILed it out. So let's just say something easy, like x plus 5 and x minus 5. If I had FOILed this out, I'd get x squared minus 5x plus 5x minus 25. These are going to cancel. And I get x squared minus 25. So what this is saying is if you notice that pattern, same binomial, one's got a plus, one's got a minus, that I could take the first term and square it, take the second term and square it, and put a minus between them, and it will save me the work. So an example of this is like A. This is the difference of two squares, so, or the product of sum and difference of two terms. So this time I could square the first term, which is 9p squared, square the second term, which is 121, and then put a minus between them. So again, save you a lot of work. The second special kind, there's two of them, and one is it's the square of a binomial, one's with a plus and one's with a minus. So if it's the exact same binomial repeated, this time the sign's not different. So if it was an x plus 5 squared, then I can square the first term, so x squared. I would square the last one and put it last, so 25 goes at the end. And then take the product of the two, so multiply these two together, that's 5x, and double it. So I get a positive 10x. If it was a minus, everything would be the same. Square the first, square the last, multiply the two together, except this time it's a minus. So it's a negative 10x plus 25. So again, just a shortcut. So if you got to something like E, I could expand that and FOIL it out, or use the shortcut. Square the first term, so that's a 9x squared. Square the last term, 49, y to the fourth squared would be y to the eighth. Multiply these two together, so I'd get negative 21x y to the fourth, and then double it. So it'd be a negative 42xy to the fourth. So again, just shortcuts helping to simplify that work a little bit. Okay, this is just multiplying more complicated binomials, so maybe instead of just squaring it, you're multiplying it 3 times. So this would be x times y times x times y, or x plus y, sorry, times x plus y. So I can use the shortcut here on these two, x squared plus 2xy plus y squared, but then I'd have to multiply it out times x plus y. So at some point, you're distributing that to both, this to both, and this to both. So just a couple extra steps, still the same process. The last thing in this section, though, is division. So when you're dividing by a polynomial, this is actually called polynomial long division. And what you have to do is divide this whole term, oh, I missed the last one, this whole term by this whole term. So you're going to take what comes first and put it underneath a division bar, just like you would if it was just a number and you're doing long division, and then divided by the 2m minus 1 would go on the outside. So this process gets a little complicated. You want to definitely follow the steps that we're doing. So the first thing to do is make sure you're going from highest exponent down to none. So this would be 1 and this would be a 0. If you're missing a term there, which you're going to see in a minute, then you have to add in a placeholder. But we've got all of our exponents this time. You also have to do that with what's on the outside. So this is m to the first and this would be an m to the 0. So again, we're okay there. We don't need to fill in anything. Once you've done that, then you've got to figure out what's going up in this space here. So I want to divide the first term here into the first term here. So what do I have to multiply 2 by to get to 4? And it's 2. What do I have to multiply m by to get to m to the third? And it's m to the second. And then I'm going to take and multiply that times both of the terms on the outside of your division bar. So hopefully if we've done it correctly, 2m squared times 2m is 4m to the third, which is what we wanted it to be. 2m squared times negative 1 is a negative 2m squared. Now typically what you would do when you're doing long division is subtract this, but I find a lot of mistakes come when people go to subtract a negative. So a trick I like to teach is changing the signs and adding. It's the same thing as subtracting, it just hopefully will avoid some mistakes. So the goal here is to cancel through the first one. If you've done it correctly, it cancels out. Positive 4m to the third minus 4m to the third cancels out. And then a negative 8m to the second plus a 2m to the second is negative 6m to the second. Now I want to bring down the next term. So this is plus 4m. And I repeat that whole process. So this time I want to figure out what I'd have to multiply 2m by to get to negative 6m squared, which is a negative 3m. And then I'm going to multiply that times each of the terms on the outside of my division bar. So negative 3 times 2m is negative 6m squared. And again, the goal there is to get it to be the same. And negative 3m times a negative 1 is a positive 3m. Go through and change your signs. And add. So this cancels like we want it to. Positive 4m and a negative 3m is just m. Bring down the next sign, which is a positive 6, or next term. And repeat the process. So what would I have to multiply this by to get to this, which is a 1/2. So I'm actually saying m divided by 2m, which would be 1/2. And then I put that at the top, positive 1/2. Multiply that times each of the terms on the outside. So 1/2 times 2m is just m. 1/2 times a negative 1 is a negative 1/2. Change your signs. These cancel, and I end up with 6.5. So you can see, I mean, that work is also over here on the other side. They've converted it into a improper fraction, but that number on the bottom, which you can keep as mixed or improper, is your remainder. So once there's no number I can multiply this by to get to here, when the variable exponent has become smaller on the bottom than it is on the outside, you know you're done. This is your remainder. So the quotient, which is the answer to a division problem, would be 2m squared minus 3m plus 1/2. And the remainder is 6 1/2, or 13/2. The other way to write this is to repeat out the quotient and put the remainder, or that 13/2, over what we originally divided by. So 2m minus 1. And you would write it like this. So depending on what kind of format you're looking for, I would say both answers are correct. They're just different formats. Okay, so now let's look what happens if we're missing a term. So let's look at this example 10. This time, remember I said you have to make sure that there's a term for each of the exponents starting at the highest down to none. And you can see that we go from 2 down to 0. There's no x to the first power. So when I write out what I'm dividing into, I would add in a 0x. So anything you're missing, you're going to add a 0 in front of it. It's a placeholder. You've got to make sure that you have it. Otherwise, when you go to add and subtract your polynomials, you'll be missing terms. And then also remember, we have to check the same thing on the outside. So that's x squared minus 4, which means I'm missing the x term. So I would put the division bar, x squared plus 0x minus 4. And now we do the same thing we just did. So what would I have to multiply x squared by to get to 3x to the third? And it's 3x. Multiply that times each of the terms on the outside. I get 3x to the third plus 0x squared. So 3 times 0 is still 0. And then I've got x times x, which is x squared. And 3x times negative 4, which is negative 12x. Change your signs. These cancel just like we want them to. Negative 2x squared minus 0x is negative 2x squared. So if we hadn't added in this term, we would have been trying to combine an x squared with an x, which is obviously not like terms. And then this is a positive 12x. And bring down your next term. First to first again, what would I have to multiply x squared by to get negative 2x squared, or what's negative 2x squared divided by x squared? And it's negative 2. Multiply it times each of the terms on the outside. Negative 2x squared plus 0x plus 8. Change your signs. These cancel. 12x minus 158. And then what's in the bottom has decreased to a power that is lower than what's on the outside. So you know you are finished, and that's your remainder. So I'm going to rewrite my quotient, which is 3x minus 2, plus the remainder, which is 12x minus 158, over x squared minus 4, which is my divisor. And that's it for, I know it's a lot of stuff that's in that section, but hopefully that's all review. Hopefully that's stuff you remember. If not, obviously we'll get some extra practice, especially on the division stuff. I know that's the stuff people probably forget the most. Okay, so then within these R.3 exercises, I'm going to highlight the ones you need to do. For the concept check here on the bottom, you're just going to do 2, 7, 4, from this page, we're going to do 11, 13, 27, 33, 43, 47, 53, 59, 67, and then 27 and 80. So here's the overall problems that you're going to do from R3. 2, 4, 7, 11, 13, 27, 33, 43, 47, 53, 59, 67, 77, and 80.